Okay, the first question is the MCQ question. Which molecular geometry is associated with a central atom that has 3 bonding pair and 1 lone pair? If you have 3 bonding pairs and 1 lone pair, so you have 4 electron domains. 4 electron domains, I have 3 cases. The first case, if all of them are bonding pairs. So I will give you 3 cases. The 3 cases are 4 electron clouds. This is 1, 2, 3, 4. So 4 electron clouds. The 4 electron clouds can be all of them bonding pairs. There is nothing lone pair of them, right? So this is bonding pair, this is bonding pair, this is bonding pair, this is bonding pair. So 4 bonding pairs and 0 lone pairs. What will be the shape? The shape will be tetrahedral. So the shape will be tetrahedral. Okay, what if I have like this ammonium molecule has 4 electron clouds also. Here the 4 electron clouds were bond pair. Here I have 3 of them lone bonding pair and 1 lone pair. So if I have 4 bonding pairs, no, only 3 bonding pairs and 1 lone pair, this is like our question, right? This is our like question. It will be trigonal pyramidal. So it will be trigonal pyramidal. What if I have water? Water, I have also 4 electron clouds, but this time the 4 is distributed. That 2 only is bonding pairs and 2 are lone pairs. So they are still 4, but 2 bonding pairs and 1 lone pair. In this case, the shape will be bent shape. My question is only about 3 bonding pairs and 1 lone pair, which is this option. So the shape will be
diagonal pyramidal.
Trigonal pyramidal. So he's asking about what is the molecular geometry? It is trigonal pyramidal. Now he is saying this is a tetrahedral electron geometry. This is a tetrahedral electron geometry. So why he is saying that is tetrahedral electron geometry? Because there is a difference between the molecular geometry, the shape of the molecule, and the electron geometry. The electron geometry is the total number of electron domains. So take care, there is a difference between the electron geometry. The electron geometry is the number of electron clouds. So it is tetrahedral electron clouds. How come it's tetrahedral, Mr. 1, 2, 3, 4. 1, 2, 3, 4. So they all of them has 4 electron clouds and tetrahedral electron geometry. Tetrahedral electron geometry. But what about the shape of molecule at the end? The shape of the molecule is trigonal pyramidal. So the answer is B. Right. What is the did you understand what is the meaning of tetrahedral electron geometry? Electron geometry is the number of electron clouds. But the answer at the end is trigonal pyramidal because it is the shape of the molecule is trigonal pyramidal. يبقى الثلاثة دول, these 3 I will call it tetrahedral electron geometry, but the shape or the molecular shape is tetrahedral here trigonal pyramidal, here bent. What is the hybridization of the carbon atoms? We explained last time. How do I know the hybridization of the carbon atoms?
We count the number of bonds.
You count the number of bonds, what electron clouds around it?
Electron cloud.
Electron clouds. So how many electron clouds around this carbon?
1, 2, 3.
Let's count again. This carbon atom, how many electron clouds around it? We said the electron clouds is the count of electron domains around it. Is this counted as 1 or 3? It's counted as 1 electron cloud. It's counted as 1 electron cloud. So this is 1 and this 1. The total is 2 electron clouds. 2 electron clouds. Then what we do?
-1.
-1. So it is 1. That's what it is. sp hybridization. Again, last time we said that if you have 4 electron clouds, it will be sp3. 3 electron clouds is sp2, and 1 electron cloud is sp. And we said that 1 bond or 2 bonds or 3 bonds, all of them are counted as 1 electron cloud. 1 electron cloud. So this is counted as 1. When he says the hybridization of carbon, so this one, and if I did the same for the other carbon, it is the same, right? The other carbon, it will be the same. It will be also 1 in the middle, and then 2 hydrogens around it, right? So if I did it for this one or for this one, it is the same. Okay, the next question is identify the formal charge on the carbon atom in CO2. Do you still remember how we count the formal charge? So carbon dioxide, It has no lone pairs. It has 2 bonds here and 2 bonds here. How do I count the formal charge? Valence electrons
minus
bonds plus lone pair electrons. Again, so valency electron. What is the valency? Valency for carbon is what?
For carbon, valence electron. We have 4 valence electrons.
4 valence electrons. What is the number of bonds?
4 bonds.
4 bonds. And how many lone pairs?
0.
0. So 4 minus 4 is equal to?
0.
0. So the formal charge of carbon is 0. Excellent. Which of the following contains a triple bond? Oxygen or fluorine or nitrogen or chlorine?
Oxygen.
Oxygen has?
No, not oxygen. Fluorine. It's not fluorine. It's nitrogen.
It's nitrogen. So nitrogen has a triple bond. So one nitrogen. Every one of them has a triple bond and 2 lone pair of electrons. That's why everyone has 8. 1, 2, and then 6. And here 1, 2, and 6. Okay, a molecule has 2 bonding pairs and lone pair. What is its molecular shape? We just said if it's 2 and 2. So the total is 4, but 2 and 2. What was the shape?
2 bonding pairs and 2. It's trigonal planar.
Again, let's remember. We said 2 and 2. It's bent shape, right?
Yeah, bent.
It's bent shape. So it is, if it is 4, 3, 4 and 0, it's tetrahedral. 3 and 1, it's trigonal pyramidal. 2 and 2, it is bent shape. Excellent. Okay. Which of the following is a polar, therefore has the highest boiling point? Okay, so there are 2 types of molecules, the symmetric molecules and the asymmetric molecules, right? The symmetric molecules and asymmetric. The symmetric like what? Tetrahedral. And what else? Linear. And what else? Trigonal, planar. These are all symmetric. And because they are symmetric, they will be non-polar. They are all non-polar. What are the asymmetric shapes? The trigonal, pyramidal, and bent. Excellent. And bent. And because they are asymmetrical, this means that the polarity will not be cancelled out. Some molecule will be polar molecule. So which of the following is polar? Must be one of these, either trigonal, pyramidal, or bent. Which one of these is trigonal, pyramidal, or bent? Mister, I do have to make every molecule. That's what I talked about. We need to memorize the molecules. So when I look at CH4, I know exactly that it is tetrahedral. CCl4, it's tetrahedral also. NH3, it's trigonal pyramidal. That's why I need to memorize them, because in the exam, if I don't know how to draw these ones already, every one of them takes 1 to 2 minutes, and the whole question has 1 minute. So I cannot take 2 minutes to draw every structure. That's why I need to memorize them. CH4 is tetrahedral, CCl4 is tetrahedral, NH3 trigonal pyramidal, and PF3 is trigonal planar. So the only one that is polar here is the trigonal pyramidal one, which is NH3. Which species possesses the shortest bond length? The shortest is the strongest. Which one is that? Is it oxygen? It has double bond. Is it O3? With O3, we knew before that it is like that. What is the meaning of this? It is shape. Yeah, is a double bond can be here or here, right? It's a resonance. What about H2O2?
H2O2.
One oxygen, and one hydrogen. So this one has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So O2 has double bond. So it has the strongest bond and the shortest bond. So it is the shortest bond. Okay, but what is next? What is next?
Next is O3.
O3. Why? Mumtaz. But why is excellent? But why? The bond order is what?
It has less bonds.
Okay, so it has how many bonds exactly?
It has two bonds, but they're single bonded.
Okay, but if I want to count the bond order, Mr. The bond order count the number of bonds and divided by the electron domains. How many bonds are here in the first one?
Two bonds.
2 bonds. And how many places the electrons are located? How many electron domains? Just one, right? There is no other place the electron can be located. There is no other electron domains in between, right? So it is one. It can be only here. The double bond cannot go here or cannot go here. It's only here. So 2 divided 1, the bond order is 2. What about here? How many electrons in this shape? Mister, let's take one of them. It's like that. So how many electrons at the end? How many bonds?
Three bonds
3
over
bonds
two.
over 2. So what is the bond order?
3/2.
1.5, right? Okay, what is the bond order between these oxygens?
We have 3 bonds.
Between the oxygens.
One bond.
1 bond, and divided by how many locations? This can be here only, right? So the bond order in between is 1/1 is 1. So the shortest one is the highest bond order, and then 1.5, and then the last one is the
1. The H2O2.
okay. This is the weakest one and the longest bond, of them. Okay. So why I2 is a solid at room temperature while F2 is a gas?
Solid at room temperature while F2 is a gas.
Okay, let's explain it slowly. Which one of them is nonpolar? Both of them are nonpolar, right? Why are they nonpolar? Because there is no difference in electronegativity, right? So both of them is nonpolar. So what kind of intermolecular forces they bond? Both of them make
London
this,
dispersion.
yes, London dispersion forces. The nonpolar molecules make only London dispersion forces. Excellent. Okay, if I want to compare the London dispersion forces between each other, so both of them I know they are weak, but which one is the weakest? The one that has more electrons, yeah, mister. The one that has more electrons will be more polarizable. Again, the one that has more electrons will be more polarizable. And more polarizable means stronger LDF. So it has a stronger LDF. A stronger LDF means it will have higher boiling point. So it will have a higher boiling point. This one has less electrons, so it is less polarizable. This is weaker LDF, and this is boiling point is lower. That's why this one is gas, right? That's why this one is gas, because the boiling point is low, but this one is solid. So, Mr.
Yes.
If I want to compare all the elements in group 7, I will see that this is gas. This is the weakest LDF. F2 is gas, right? And because it has the least number of electrons, it has 9 electrons and 18 electrons only. And then there is the Cl. Cl2 is gas also. So the intermolecular forces, the London dispersion is stronger, a little bit stronger, but it's still gas. Why? Because 17 plus 17 is 34. And then the bromine boiling point is what? Is a little bit higher. Why? Because the number of electrons is more, right? 39 and 39 is 78. You see the number of electrons is more, right? The number of electrons is more, so means it's more polarizable. It's stronger LDF. It's higher boiling point. The stronger the bonds, the more energy you need to break the bonds. That's why the boiling point is higher. So it instead of being gas, it is what? The bromine
It is
liquid.
or
Liquid. And then the one which has the strongest bonds is the iodine. Iodine and astatine, both of them are solids,
solid.
right? They are both solids. Why they are solids? Because they have the highest boiling point in all of them. Sorry?
Yes. More polarizable.
Yes, more polarizable because more electrons. So every time he asks me about the boiling point or melting point, I should mention the type of the bonds in between. This is a rule in chemistry. If he asks me which compound has a higher boiling point or melting point, I must tell him what is the type of bonding in this structure. Because the type of bonding will determine the strength of the bond, right? If it is strong bonding, then the boiling point will increase. If it is weak bonding, then the boiling point will be less. Why? Because here you need more energy to break the bonds. It's stronger bonds, so you need more temperature, more energy to break the bonds. While here it is weaker, so you will need less energy to break the bonds. That's why you need less temperature. Boiling point is less. If you are having an ionic bond, the temperature for boiling point or melting point of sodium chloride is very high. Why it is very high? Because the bonding is very strong, Mister. This is ionic bonding, right? It's very strong. It's very strong bonding. That's why the melting point of the sodium chloride, we said it's almost 2000, right? Well, it's 800.
Yeah.
I think it was 800. It's a very big number. It's a very big number. Okay. Well, let's see the next question. In the best Lewis structure for SO4 minus, how many double bonds are used to minimize formal charge?
Formal charge.
Mhm.
Calculate the formal charge.
In order to minimize, it has to be 2 ولا 0 ولا 1 ولا 4. Let's do the structure. Let's practice and draw SO4 2 minus, a good chance. So S, 1 atom, and oxygen, 4 atoms. Every one of the S has 6 electrons because it is in group 6. And then every one of those has 6 electrons because it's still in group 6. So 4 into 6 is 24 electrons. Do we add or subtract any? Mister, this is SO4 2 minus. So you have to add, you have to add 2 electrons. So 6 plus 24 plus 2, the total is
30.
30
24.
electrons. And we said we need to know the number of pairs, how many bond pairs or lone pairs. So I have to divide this number by 2. Why?
Double.
Because every pair has 2 electrons. So to know the number of pairs that you have to make 16 pairs. So this is the sulfur, and there are 4 oxygen atoms around it. Where is the first pair? This is my first pair. Second, third, fourth, fifth, sixth, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm lost. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have the 16 pairs right now. Let me count them again. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pairs. There is no lone pairs. But is the structure okay now? Is it fulfilling the octet rule?
مش لازم يكون في bond يعني مثلا single bond.
There is the bond. This is the bond. The 2 electrons made the bond, and this is the bond, and this is the bond. So I have 4 bonds. I can see the sulfur has 8 electrons around it. I can see the oxygen has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons around it, and this one has 8 electrons around it, right?
Yes.
So it has 8 electrons around it. Everybody is satisfied. So these 6 electrons, 6 into 4 is 26, and 2 electrons to 32 electrons. I have this type of bonding 1, 2, 3, 4, 5, 6, 7, 8, and everyone is satisfied. How many pairs you have? 1, 2, 3 into 4 is 12, and then 4 is 16 electrons. So that's sulfur and satisfied. How many double bonds are used to minimize the formal charge? Let me check. What is the formal charge of this one? So the sulfur has a formal charge of what? Mister, it is 6, and then
6 minus bonds, so
yes,
4 bonds
and then
plus 0.
0. So the structure is 6 minus 4, so it is 2. So it has He's asking how many double bonds are used to minimize formal charge. Can we make it less? So the formal charge here is 2.
6.
Is 2, right?
2.
Can I make it less? Because if it is less, it will be okay. Let me try to draw another structure. I will take 2 bonds from here. I will take 2 electrons from here and make it a double bond. Let me see. But Mr. Y, it's all octet. Yes, it's all octet. But we said last time that the elements which are in period 3 can carry what? They can carry more electrons, right? They have extended octet. So if I am able to make more than octet and make the formal charge less, it will be better for the structure. So I will take only one of the lone pairs from here and use it to put it here, right? Make it as a double bond. And then this oxygen will be enough. So it will be 1, 2, 3. And then this is the same, no change. 1, 2, 3. And this is oxygen 1, 2, 3. So the only change is that I took only one of the electrons from here and then kept it here, right? Is it following octet, Mister? This is 1, 2, 3, 4, 6, 8. So oxygen is satisfied, and the other oxygens are all satisfied. But Mister, the sulfur is not 8, it's 10. This is 4, 6, 8, 10. Is this fine for the sulfur? Yes, sulfur has extended octet. Has extended octet. So it is more than 8. It's 10 electrons. Is this fine? Yes, because it's in period 3. Okay, what is the benefit? Why I did that? It was octet and everybody was happy. Now let's try to count the formal charges now. The formal charge of the sulfur is what?
What does extended octet mean?
Extended octet, we said that it has more than 8 electrons around it. And we said this happens in the elements in period 3. So again, we said that there are 3 types of elements. Most of the elements, they need to have 8 electrons, right? They need to have 8 electrons around it. But 2 elements can have 2 only, right? Hydrogen and helium. Can they have 8? No, they cannot have 8. The maximum that they can have is 2. What about boron, carbon, nitrogen? Boron has deficient, right? So BF3, is this 8? No, it is what? There is less than 8, but it's still fine. What about carbon, nitrogen, oxygen, and fluorine? No, they must have 8, right?
Yes.
But what about these ones? These ones can have more than 8. What is your proof, mister? There is something called PCl5. PCl5. Mister, it has 5 chlorines around it, so it has 10 electrons around it. Oh, that's extended octet. It's extended octet. Why, mister? Because they have 3D. They are in group 3, in period 3, so they have 3D. So they can take 2 more extra electrons and put them in the 3D. These ones, they don't have 3D, right? They don't have 3D. So these ones in period 3 and the lower ones, they have d orbital, empty. It's empty, right? It's all empty. So they can put electrons in it. So it's okay to be more than 8. It's okay. Mister, but my question is, that was octet and everybody was happy. It was octet and everybody was happy. Why did you change it into extended octet? You were not forced. There is nothing to force you to do this. If you told me that it must be octet, like here, for example, PCl5, there is 10 electrons. You cannot make it 4, right? Because there are 5 atoms. But here you are, okay, mister, I'm doing this to reduce the FC, to reduce the formal charge. Let's see the formal charge of the sulfur now. Is it more or less? What did I do? I took 2 of these electrons and make a double bond here, right?
Yes.
So what will be the formal charge? It's 6 minus
البوند اللي هي 5. That's 0.
Oh, mister, so the formal charge now is
1.
1. That's much better, right? I have decreased the formal charge. Can I do even better? Can I do better? Yes. You can take 2 of the, you can make 2 double bonds instead of 1. You can make 2 double bonds instead of 1. So it will be, I will take 2 more from here. So it will be double bond here and then oxygen and then oxygen. This oxygen still 8 electrons. This one is 8. This one is 8. Okay. So I took 2 more from this one, right? Now what is the formal charge? 6 minus
minus 6 plus
plus
0.
plus 0. So the formal charge now is 0.
0.
Mr. This oxygen is okay. It has octet. This is okay, has octet. This is okay, has octet. This is okay, has octet. This has 2, 4, 6, 12. Is it fine? Yes. Yes, it's fine. But why I did that? I did that because I made the formal charge 0.
Is there a number of electrons in an extended octet?
Sorry?
Is there a maximum number of electrons in an extended octet?
Actually, if you think how many electrons it can have 10 more electrons. Oh my God, yes. It has 5. It has the 3D orbital empty. Can you see? It can put 10 more electrons extra. More than 8. That's more. That's 10 electrons extra it can put. Okay? Mr. So the question is saying in the best Lewis structure, how many double bonds I needed to minimize the minimal charge? Mr. I was able to put 2 double bonds. And that's my answer. I was able to put a 2 double bond, and this minimized that minimal formal charge. I made it 0. Okay, Mr. I want to say something. This is a very, very important question. This is a very, very important question. Okay, let's see. Predict the bond angle in NO2 minus. Let's draw NO2 minus together. So NO2 minus is?
N in between.
Yes.
And then double bonded O.
To each one?
Wait, 1, 2, 3, 4.
Let me tell you, in the exam, I have 2 options. I don't have a third option. What are the 2 options? I have memorized the shape and I know it by heart. So I have memorized the shape and I know it by heart. The other option is to draw it by the steps. So count the electrons, put it inside. There is no other third option. You cannot make it up. So either you memorize it, you know how it looks like. Like I ask you, NH3, Mr. I've done it 100 times. It's like that. Oh, how did you know? Oh, Mr. I've done it 100 times until now. I know it. So either memorize it by heart or do the steps. What are the steps? Count the electrons, add the negative as 1, and start putting it. But there is no third option. So N is 5. Oxygen is 6 times 2. And then add 1 extra electron because there is a negative. So how many electrons total?
5 times 6, 30. Plus 1. No.
So there's 12 plus 5 plus 1 is 18. Again, how many pairs? How many pairs do I need to put? 18 divided by 2. So 9 pairs. So this is the oxygen. How many pairs I can put? I can put 1 pair here, 2.
2.
And then I need 6. I need 7 more pairs. Right? I'm
So
done.
1, 2.
I can put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Huh? How many pairs I have placed now? 1, 2, 3, 4, 5, 6, 7, 8. There is 1 more. Where do I put the other pair?
On nitrogen.
On the
Between nitrogen oxygen.
Let me put it on the nitrogen itself, right? Let me put it like that first. Okay, now this is not octet for sure, right? Because the nitrogen has 6 only. And whenever the octet is not there, what do I have to move?
1 pair.
1 pair and put it in between these 2, right? So let's see. If I put it like that, is it okay? Now everybody is happy?
Yes.
Okay, so everybody is happy now. The shape is NO2 minus. Mister, but there is another option. Don't always forget there is another option. What is the other option? Why did you put it on this oxygen, right? You could have placed it on the other option. Whenever there is 2 options, you can make the resonance, right? Right?
Yes.
You could have put this to here, because why not? So there is a resonance in between. Let's remind ourselves, like the last time, one of the papers of the A4 paper should be NO2 minus, so that when I'm in the exam, I will flip it around. I will not have it in the exam, but I will have it in my mind. Instead, it's NO and O. What should I can draw it like that? I can draw it like that. Half and half, right? Which means it can be here or it can be here. Okay, what is the shape? How many electron clouds around this? Three electron clouds. 1, 2, 3 electron clouds, right?
Yes.
Why is -2? It's 2 only, not -2. It's -1. The other one is the same. It's how many electron clouds? 3 electron clouds. So 3 electron clouds, one of them is a lone pair. What is the shape?
The shape is diagonal.
It's bent. It's a bent shape, right? It's bent shape. Is it 180, 120, 109.5?
It's not 180 صح؟ لأن it's not linear.
It's not linear. It's not linear. There are three.
It's not 120, 109. It has to be in C.
It has to be tetrahedral, but it's not tetrahedral. It's bent. So it is 104.5. That's less than 120.
Yeah.
Okay. So this is the shape of the molecule. That's why I said memorizing make the things very, very easy. Memorizing make it very, very easy. And it's done only by practice. You don't have to force your mind. You don't have to force your mind to memorize it. You just have to do a few every day. Like let's say if you do every day 5 and keep repeating, that's just flashcards, then keep repeating it, else you will know it. Okay, let's see the next one. Formal charge, draw the resonance structure for NCO minus, justify the most suitable stable contributor. So let's try to make NCO minus. NCO minus. This is group 5, so 5, group 4 to 4, group 6, so
Group 6.
and then add one more because of this thing. So how many electrons? 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 6 is 16.
هيبقى 16. أيوه.
Divided by 2, so it is 8 pairs, right?
Yes.
Okay. So where I keep the N and where I keep the C and where I keep the O. We know that the most electronegative element should be the least electronegative element, right? The least electronegative element should be in the middle. So what is the least what is the least electronegative of them? The carbon, right? The carbon is the least electronegative. So I'll draw C and then I will draw O and then I will draw N. Okay, what I will put? Single bond.
So we will count the pairs. So 1, 2, but then on carbon 3.
I will put how many on the 3?
We put 1 on carbon.
1 electron or one lone pair?
1 lone pair.
Okay, and then on carbon?
لا 1, 2, 3.
I have how many pairs remaining? I just did 2 only. I did this one and did this one. So I have 2 and there's still more 6. So let's put 2 more here at least, right? Let's distribute it 1, 2, 3, 4. Oh, I still have more. 5, 6. Let's distribute it like that, right? So 1, 2, 3, 1. And this is 1 pair. 2, 3, 4, 5, 6, 7, 8. There are 8 pairs here. Okay, is anybody satisfied? Only the carbon is satisfied, but the nitrogen is not. 1, 2, 3, 4. So I need to make what? To
We
put
change the,
a
yeah,
double bond here. So I will take this one and I'll put it here. Now this is satisfied, right? Because
yeah.
there is 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The oxygen is not satisfied. So I have to take
Oh,
this double bond and move it. Where should I take?
carbon. We take from the carbon,
We take from the carbon
double bond,
and put it like that. So it will be
a double bond.
double bond. So now the carbon has 8, oxygen has 8, nitrogen has 8. Everybody is happy. Okay, this is one shape. This is one shape of the shapes. Can we do more? Let me
Yes.
see, Mister. Let me see. Can we do more? Can we do anything else? We can put nitrogen, and then we can put carbon, triple bond, and oxygen. So we'll distribute it like that. This is triple bond, and this is 1, and then 1, 2, 3, 4, 5, 6. So 8, and then 4, and then 8. That's also correct. Is there one more? I can have the carbon here in the middle with triple bond with the oxygen. And then this is 8, and that's 1. This is one of the structures that I will say it will be a great idea to memorize because it's really nauseating. So I can have here 1, 2, 3, 4, 5, 6, 7, 8, and this 8 and this 8, all are suitable. Okay, now I need to know which one is the best one of them, right? To draw the 3 resonance structures. They are all possible structures and they are all okay. And the most suitable one is, which one is the most suitable one?
Um,
Let's see the formal charge of every atom of all of them, of every atom of all of them. So formal charge of nitrogen here is
uh,
5, 5,
4,
5 minus
5 minus bond, يعني 2,
2
uh, 2,
plus lone pairs are
4,
4,
أيوة. 5 minus 6, يعني negative 1.
negative 1. And here 5 minus
5 minus 3
3 plus,
plus 2.
which is 0.
Equal,
And here 5 minus
5 minus 1
plus
plus
6,
6.
so negative,
So minus 7. اللي negative 2.
negative 2. Formal charge of carbon, it's always
Carbon
4
4
minus
minus 4 plus 0.
4 plus 0. Here 4
Minus
plus 0, and then 4 plus 0. There is never lone pairs, right? It's always
0.
0. It's always 0. All the structures are good for the carbon. And formal charge of oxygen is 6, always minus
Minus 4. لا minus 2.
minus 2 bonds and 4
Plus
lone
4.
pairs. So it is
0.
0. And here
Minus 1 plus 6.
6,
يعني negative 1.
negative 1. And then
minus 3 plus 2. يعني negative لا 1.
what is plus 1 or 1. Okay, Mister, I can see that there is like I don't think that this will be a good one at all because there is negative 2 and there is 1. The numbers are not okay. Is this a good idea? And here I have 0 and 0, but this oxygen only has negative 1. So what is my rule here, Mister? The rule most stable has negative formal charge on the most electronegative atom. So I have the most stable of them will have a negative formal charge on the most electronegative atom. Which one is the most electronegative atom? The most
Oxygen.
electronegative atom is oxygen. So I'll write here the most electronegative atom is oxygen. Should have the smallest number, the most negative. So it has a negative formal charge. This one is 0. This one is -1, and this one is 1. So in this case, which one will be the winner? This will be the winner. So the oxygen atom formal charge should be -1. So this is the good structure. This is the best structure. It's very important because sometimes in the exam, I will see the numbers different, or I will see two numbers which are 0. Like, for example, I will see C and oxygen and C and oxygen. One of them is 0 and one of them is 0. This one will be 0 and this is -1. So I will say this is the most electronegative element and it should have a negative on it. So this will be the good structure. Okay. Again,
Yes.
whenever you have two atoms, two structures with the same similar formal charges, the most electronegative atom will have to have the smallest formal charge of them. Okay, compare the CO bond in CO2 and CO3 2 minus, a very common question. It comes a lot. You'll see it in the other exams and questions. So see the CO and CO2 in these two, which one is structure is easiest? Mister, of course, see, I have drawn many times in the past days while revising, and I saw that it is like that. So how much time I have saved because I drew this in 1 second? I saved a lot of time in answering the question. What about the carbonate? I don't remember it very well, but I remember that there was a kind of resonance in it, right? There was a resonance on it. It was made from 1 carbon and 3 oxygens,
Three
right?
ox
3 oxygens. Okay, Mister, either I memorize it or I make it. I don't have an option. Either I memorize the shape of it or I make it myself. Huh? Do we memorize it? Mister, it's a
Yes.
resonance. The resonance are the ones that I should memorize the best. So it is, I should start memorizing with the easy ones, and then if I don't know the easy ones, I should know them. If I know them, then I should move to the resonance structure very fast. So there is 1 carbon, and this carbon has an oxygen here, and oxygen here, and oxygen here, and 2 minus here. This one is made from 1, 2, 3, 4, 5, 6, and there is 1 single bond. There is a double bond here and single bond here, and this is 6, and then you keep shifting, and then you keep shifting. The other one has the double bond with this one, and this has 4 oxygen, 4 electrons, and the others are 6 and 6. And the third one is the carbon with this oxygen on the last one. So what time it was here, one time is here, one time it is with this one. The one that has double bond has 4 electrons, and the one that has single bond has 6 electrons. Mister, again, if I memorize this exam, how much time I have saved? Okay, anyway, we are done with this. Let's look at the bond order. Do you remember how we made the bond order? 4
uh,
electrons divided by,
divided by lone pairs.
again, 4 electrons, no, 1, 2, 4 bonds. 4 bonds divided by how many places to put them? 2 places. So it is, bond order is
2,
2. Okay, what about here? I have 1, 2, 3, 4 bonds, but divided by what?
3.
3. So it is 1.33. So which one is stronger? Again, Mister, how did you do that? This is 4 bonds divided on 2 areas. Here, 4 bonds divided by 3 areas, right?
Yes.
So the stronger one is
The 2.
the 2. This is stronger and shorter. Its bond order is 2. The other one is bond order is
1.
1.33. This is longer, right? This is longer bond order. So bond order counts the number of bonds around the atom and divide them by the electron clouds around it. Take care, the electron clouds around it. So don't count these electron clouds. Don't count these electron clouds, right? I'm talking about the electron clouds around the carbon only. Around the carbon only. Okay. This is FRQ 3. CCl4 is insoluble in water. CH2Cl2 is soluble. Justify. Mister, in order to dissolve in water, water is polar. So water is polar. And in order to dissolve in water, you have to be polar because polar dissolve in polar. Non-polar dissolve in non-polar. Okay, CCl4 is what?
Is non-polar.
Yeah, because it is what?
It's tetrahedral.
Excellent. So tetrahedral, and tetrahedral is asymmetric. Is symmetric. It's symmetric, Mr. It's symmetric. So it is non-polar, Mr. So it is non-polar. That's why it is insoluble in water. What about CH2Cl2? CH2Cl2.
Uh, it's
It's
bent.
It's polar shape. It's polar shape. How did you know, Mr. It's polar shape? The attraction is not the same, right? They are pulling down. These two are pulling
So
down. The direction of polarity is like that. So this is polar shape because
bent.
it's asymmetric shape. It is asymmetric shape. Okay, so it is polar, Mr. If it is polar, then it dissolves in water. Yes, it dissolves in water. So this is symmetric nonpolar. The water and CH2 CO2 are both polar, and polar like dissolve like polar dissolves in polar. Okay, hybridization. Identify the hybridization of all carbon atoms in CH. All carbon atoms. So I will number them. This is carbon atom number 1, and this is carbon atom number 2, and this is carbon atom number 3. Can we know
Three.
the hybridization of every one of them? Let's look at number 1. Hmm.
Um,
Hybridization count what around the atom?
for a bond.
Count
Minus one.
yes, the electron clouds. So how many?
So electron clouds. 4 minus 1
So it
is
is
S for C1 sp3.
Mumtaz. Excellent. C2
We have 3 electron clouds.
more than excellent. 1, 2, 3. So it is
Minus 1, so sp2.
excellent. And then C3
3 electron clouds. Minus 1 sp2.
excellent. So this one is sp3. These two are sp2. That's more than excellent. Okay. And then next one, explain why SF4 has ESO shape instead of tetrahedral.
Because it has an extended octet.
Oh,
ولا
okay. Okay. It has extended octet, yes, but there is still something remaining to explain. In order to be tetrahedral, it has to have 4 bond pair and how many lone pair?
1.
No,
لا
0 lone pair, right? 0 lone pair. This is tetrahedral. Like what? Like CH4. How many bond pairs? 4.
4.
How many lone pairs? 0. What
0.
about this one? If I draw this one, Mister, I should draw it or memorize it again. So if I draw it, how many electrons it has? S is 6 plus. That's what I'm saying. Either memorize it or draw it. There is no third option. You cannot guess. You cannot guess it is without lone pair or with. If you don't know it, you have to draw it. So 4 multiplied by, this is
4.
group 7. Group 7. So 4 multiplied by 7 is 28, plus 6 is
4.
34. So how many pairs?
4. Yes.
17, right?
Yeah.
17 pairs. Let's draw 17 pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There is one extra pair. So again, this is 2, 4, 6, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34.
34.
I didn't count correctly. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. 16, so 32 electrons. There is one more, there is 2 more electrons. Where should I put them?
On S.
On S. So this is not 4 bond pair and 0 lone pair. This is 4 bond pair plus one lone pair. And this shape is not tetrahedral. This shape is
Uh,
seesaw shape. This is a
oh,
seesaw shape. So it would have been tetrahedral if it has zero lone pair, but unfortunately it has one lone pair. That's why it is seesaw and not tetrahedral. Predict and justify the HOH angle in H3O plus. H3O plus. This is three hydrogens. One of them is done by the electrons of the oxygen,
uh,
right?
yes.
What is this shape called? What is this bond called? It's a covalent bond called what? This is not a normal covalent. This is called a coordinate, right? This is a coordinate covalent bond. Why it's called coordinate? Because the electrons came from the oxygen. The electrons came from the oxygen. This is a proton. It has no electrons. In order to make the bond, I used the two electrons of the oxygen to make this bond. I used the two electrons to make this bond. Okay, what is the shape now? Mister, how many bond pairs and how many lone pairs?
Bond pairs, 3. Lone pairs, 1.
One. And what is this shape?
Coordinate.
No. Coordinate is not the shape of the molecule. Coordinate is the type of covalent bond. There are two types of covalent bonds. The normal covalent bond, the regular covalent bond. It's not called normal or regular. It's called a covalent bond. What is the meaning of a covalent bond? Two atoms are shared. This carbon has an electron and this hydrogen has an electron. They share it together. So this means that an electron from each atom. How many bonds I have done here? I have done one covalent bond. Where did you get the electrons for it? One from the hydrogen and one from the carbon. The other type of the covalent bond is called the dative or the coordinate. It's sometimes called coordinate or the dative covalent bond. What is the difference? Mister, the bond is between an oxygen which has a lone pair of electrons and the proton. Mister, this is the same. Hydrogen and proton the same. Is hydrogen and proton the same or they are different?
Same
Hydrogen,
and different.
hydrogen atom and hydrogen ion, are they the same thing or different thing? It's different. This one has an electron. This one is just a proton. It has no electrons. It's only a proton. It has no electrons. So if you want to make a bond, this is a bigger. Do you know the biggers? This is a bigger. He has no electrons. So in order to make the bond, who is going to give the bond, the electrons? The oxygen. The oxygen. He is the rich guy. He will give the two electrons from his side. Mister, what is the difference? The carbon here give how many electrons for the bond? One only. But here the oxygen give two electrons. Why did the oxygen give two electrons? Because this guy has nothing. This guy has nothing to make the bond with. That's why when I draw the bond, I will draw it like that. Why did I draw it like that? To remind the hydrogen that I am the rich guy. I am the one who give you the bond. I will not draw it like that. Here I draw it like that. This is shared company, right? But here this guy is reminding him, remember, I am the one who give you the electrons. This is not related to the shape by any means. I was just saying that it's a coordinate covalent bond. It's done like that, H3O plus. This not related to the shape. The shape is get from the three bond pairs and lone pairs. What is the shape of three bond pairs and one lone pair? We explained this at the beginning of the day. Three bond pair and one lone pair is
Trigonal pyramidal.
diagonal pyramidal, and this is the same without exception. I was just explaining what is the dative because this is actually a dative bond. This is a dative bond, but it's not related. At the end, it's a covalent. So three bond pairs and one lone pair, it is a trigonal pyramidal shape. 107, right? 107. Identify the number of sigma and pi bonds in CH2, CH2.
For both. لا, one bond is sigma
One bond is sigma
وده is pi.
and the other bond is pi. And
No,
here,
one sigma, one pi, one sigma, one pi.
okay, and then
يعني two
this.
sigma, two.
What about this?
طيب يعني 1 2 3 4 5 6 sigmas
So I have 6 sigma, and I have how many
and
pi?
pi.
So I have 6 sigma bonds and
2
2
pi.
pi bonds.
مش العكس.
It is opposite. Yeah, I'm sorry. And still after effects of breakfasting. Sorry, I'm so sorry. 6 sigma and 2 pi. Okay, so sigma and 2 pi. Okay, that's excellent. Question number 8. Why all NO bonds in NO3 minus are identical in length? Mister, if I draw NO, it will be like that. NO, and then minus. And how many electrons are there? There is 5 plus 18 plus 1. So 24 electrons. So 12 pairs. 1, 2, 3, 4, 5, 6, 7, 8,
9
9, 10,
and
11. Let's count the pairs again. 5 plus 18 is 23 plus 1 is 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then there is one more, right?
yes. You can put, yeah,
1, 2,
12.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is this octet? No, youngster. It's not octet. So you need to take 2 of these electrons, make it a double bond here. In this case is,
Extended.
it's not extended, it's normal. It's normal, it's 8. It's normal octet. Extended means more than 8. It was not 8, it was 6, right?
Yeah.
It was 6. So it's not octet, so it's not correct. I have to do like that. So it's double bond with this one. But there are 2 other options, right? I can put the double bond here, and this stays as single. Or I can put the double bond with the last one. So this is a resonance, right?
Yes.
The difference between them is that one time the double bond is here, one time it is here, one time it is here. But in all of them, it is octet and correct. So what is the proof that they are all identical in length? Because the bond order is the same in all of them. What is the bond order of them? The number of bonds divided by the regions. How many bonds around
We
the
have
nitrogen?
4 bonds
Over
over 3.
3 regions.
1 2.
3 regions around the nitrogen. So 1.33 in all of them. The bond order is 1.33 in all of them. And if you counted the formal charge, it is the same. Formal charge in all of them is 5 minus 4,
Minus 4
minus
plus
0, right? So it is plus 1 in all of them, right? Yes. 1 in all of them. That's why they are all identical in length, because the bond order is the same in all of them. Last 2 questions explain why PCl5 exists, but NCl3 pipe does not exist. This is a very, very important question. Very common to come in the exam also. Mr. PCl5 exists, so we can make an extended octet in that, but NCl5 does not exist. It's a pity that some of the students know the answer but don't write it correctly. Some of the students will say the reason is that phosphorus can have extended octet, which is partially correct, because you should explain why. So phosphorus can have extended octet. Why? Because it is in period 3, and we said period 3, period 4, period 5, it can have an extended octet. Nitrogen is not in period 3, it's in period 2, and period 2 cannot have extended octet. You cannot have 5 electrons. Its maximum is 8. Maximum is 8 electrons around it. You cannot have extended octet. This is part of the question or answer. We should have add one more idea. Why? Because they have access to what? To
Yeah.
d orbitals, because they have empty d orbitals, and d orbitals is 10. You want to add 2 more electrons on it? Don't worry, I have space for even more. So this is
No.
the rest of the answer, because they have d orbitals for expanded octet, while NCl5 don't have d orbitals. Why Xe4 is nonpolar despite having lone pair in the central atom? So Xe is 8 because it's in group 8, and F is 4 multiplied by 7, so it's 28. 8 plus 28 is 36 electrons divided by 2, so 18 pairs. So Xe and then F4. How many pairs did you draw? This is
4.
1, 2, 3, 4.
4.
I have 14 more.
So 1
1,
and
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is two more pairs. So I
on
should,
Xe.
I have 2 more on the Xe. So it has 2 lone pairs and 4 bond pairs. This is called a square planar. And square planar, the polar bonds cancel out. The polar bonds cancel out. Okay, that's why it is a non-polar shape. It is non-polar molecule.
Okay.
Okay,
No.
I think that was all for this 10 questions and then 20 MCQs.